Good afternoon or good evening, students, everyone. I hope you are doing well today. So, welcome to our third session, Carol problem solving, even though it's a section second, I would say. Before we dive in, how did you guys are able to, how did everyone find the last lesson? That is session one exactly. Uh, the hospital Carol problem. I hope most of you have gone through it. And I wish the same. If you have any doubts, place them in the comment section or in the form in our code in place platform. Okay, so awesome. In today's session, we are going to solve a fun problem with our robot friend, that is Carol. Okay, so you're gonna see how powerful a simple logic can be, even without the variables or counting. So in today's problem statement, what we are trying to do is, let's look it out. So let's look at our today's challenge, which is called as the spread Carol. Here is the setup, which you can see here. This is the entire setup. Okay, what is our job is Carol start in front of the pile of the beeper at cell 1. The beepers are in cell 2. Your job is to help the Carol to pick up all the pile and spread the beepers one per cell, starting from where the pile was. So if there are seven beepers stacked in one cell, we want the result to be one beeper at each of the next seven cells. Simple? Okay. But here is the catch. Carol cannot count and start with infinity beepers in her bag. So we can't use the number or memory. So we need to solve it just using the action and the loop. So in order to do that, let us understand a simple strategy that we're gonna think of to complete the task. Let me minimize the session. Okay, since I minimized it, let's remove this part. Since the Carol cannot count and start with infinity beepers in her bag, so we can't use the number or the memory. So in that case, we just have to use the actions that was provided earlier. So what is a pseudocode that I come up or that is coming up in my mind right now is the strategy. Um, in let's think of, since we can't store the values, the step one, it's simple, would be move to pile of papers first. Step two, while there are papers in the pile, pick one paper. If there are still papers left in the pile, mm, walk forward until there is no paper. Place the paper, return back to the pile. And step three, when only one paper is left in the pile, put them put that paper down in its original place. And step four would be just need to go back to the starting position. Because in this problem statement, you could see after completing the operation, the Carol is at the same position as it was in the before. So at the initial position. So we need to make sure that the after completing all the operation, it have to come to the starting position itself. So So this is a thing. This is pseudocode or the strategy that I come up. So simple manner, I will understand. I will make you understand. So since the Carol is in the cell one, it will go to the cell two, and every time the pile or the stack of the beepers will be present in the cell two itself. So the Carol will go to the cell two. It gonna take one beeper or pick one beeper and place it to the second cell, and it will come back to the the stack of the beeper place, that is cell 2, and will pick another beeper and go to the next cell. If the cell is present, it will ignore that position and will go back to the next cell to place it. If there is another pile, if there is another beeper is already present, it will ignore that position and will keep it to the keep at the another cell. So this is the operation that is going to perform until there is only one beeper left at the cell 2. Once it will identify there is only one beeper is present at the cell 2 position, it will leave as it is and it will come back to its initial position. That is the entire operation or the entire strategy that is being we are going to follow. So in order to let's start by writing the code. Since we are already know, okay, so we can import anything. So def min, so we are writing in the main function. So first we have to move to reach to the to move to the pile of beepers, then spread. That is a function to start spreading the beepers that we are writing. It is a custom made one. Step back. It is the step 4. That is return to the starting position. That is the 3 operation. We are moving to the cell 1 here, sorry, cell 2. Sorry, cell 2. After moving to the cell 2, we're gonna perform 2 operation in the spread function that is a custom made. That is picking up the beeper and placing it to the next cell where there is no beeper is present until the only one single is been present at the cell 2. And once there is only one cell is been present, it will go back to its initial position. So since we have already defined the move is a built-in function, so we don't have to write any function for it. Since spread is a defined, we are defining, so we have to write the code for it. Spread for spread while beeper is present, we have to move it, right. Means we need to keep going while there are beeper. If there is no beeper, then it's not a case, right? So we need to check whether the beeper is present or not. So once after that, what we have to do is we have to pick the beeper. Once you pick the beeper, if beeper is present, move to end. Okay. Here the operation is simple. Pick one beeper. Okay. Then if it is not the last one. I mean, if it is not the last one beeper, then we have to move to the end position. End means we have to go on till there is no beeper is present at a particular cell. So that means go to the next empty cell. So while writing the Karel code or Karel codes, I mean the Python, always try to write in the simple high-level language or in the simple high-level code or the high-level hierarchy, I would say. High-level hierarchy in the sense instead of going to the deep built-in functions like the move next or pick the beeper or place the beeper, go with writing in a normal understanding manner or the high-level hierarchy manner. That is like what we have understood in the pseudocode. Try to write in that particular position, and every time when you define a new function, try to write that custom code for that particular function that you have created. So it is very much useful because in most of the cases in the Karel, we have to use the modularity. That means we have to use a particular function again and again. So instead of writing that piece of code or the piece of or the stack of the code where again and again, it would be very much difficult. So try to create a custom function for it so that it can be used any part of the time in the longer code, in the longer session, or in the longer time period of time. So once we have gone to the last cell, just you need to put the beeper. Once placing the beeper, you have to go back to the, this is putting the beeper means, drop the beeper there. Once you reach the placing that back to the file. Okay. Now after that, put beeper. That means placing the last beeper at the cell 2. So what is the custom one that we have created? That is move to the end, because remaining all are the built-in one that is already present. So we just created that depth. Move to the end, the custom one. So we have to write the code. Move to the end can be checked like every time we have to check if our next cell is already been placed with a beeper. If not, we can place it. If it is present, we have to move to the next cell. So that's how it is done. So while beeper is present, we can't do anything, just move till there is no beeper. Okay. So there was another custom made function that we have created. That is nothing but reset. That is coming back to the top of the file. For reset, what we are trying to do is turn around. Turn around is not a move to wall. Turn around. So what is exactly is happening is, since beeper is always moving in the east direction, so it just have to turn around to face the west direction until it has to reach to the last wall. What here is happening is, it will move till it reaches a particular position where it will places the beeper. And since it is facing the east direction, it has to face the west direction. For that, it has to turn around till it reaches the wall. Once it reaches the last wall, I mean the wall, this wall, so it will once again turn around and it will move to this position. So indirectly we are coming to the top of the stack of the pile, I mean the stack of the beepers again. So by with the help of this, yeah, we are all done. So let's complete the remaining part of the code. So once we have reached, with the help of this, we have reached to the top of the stack of the beepers that it was present. Now define move to wall, since it was a custom made. So while front is clear, if front is clear, move. So what exactly is happening is, move to the wall until front is locked. Okay. Now def for turning around, what we have to do is just we need to rotate it 2 times left position. That is turn left, turn left. We don't have to worry about the turn left function. It is a built-in function. So after that, step back. After identifying there is only one beeper is present in the cell 2, it has to come back to its initial position while facing the east direction. So for that, we have written a custom function that was the step back. A step back, what is that? Turn around, because it will be facing in the east direction. If you clearly see it, it will be facing in the east direction, because after identifying there is only one uh, beeper is present, it will be in this position, in the east direction position. So it has to turn around. Once again, it has to move one position over here, and then it has to turn around again. So that's how it is. So if turn around, move one position to reach the cell 1, and once again turn around. That's how it is. Let's delete all the drawings. Then let's run it. Okay. We could see that it is picking one beeper and placing it back. Once it is identifying there is only one, so it is coming back to its initial position. Okay, so it was very nice to solve this. So let's go with some edge cases. Uh, let's talk about what might go wrong while writing the code, how to handle it. See, what if there was only one beeper? No problem. Carol just place it back at the original location only. What if there is a long row? Carol doesn't count, so it will just keep going forward until she because Carol is considered as a she, so don't worry about it. If I say Carol as a she, so she find no beeper and place the next one. Okay. What if we use variables to count the beepers? So as I mentioned earlier, if what happens since I can't use the count thing, see Carol does not support that. So this solution is perfect. I won't say perfect, it is ideal one. Okay. You could come again with a different solution also that is also highly acceptable if you come across it. So not a problem, but is the ideal one how to solve it. Okay, so wrapping up this entire session. So, all right, everyone, let's very much thank you about it today's session. Today, we have learned how to break down a problem, writing the pseudocode and turn it into a real code with proper logic using only the Carol movement. We have never used a count variable here. Okay, we also learned how to stimulate the memory without using the variables by using the physical movement, which is a big idea in the computer science. Okay. So next time we will explore how to make Carol to do more complex, like working with multiple rows or the patterns also. Before you go, uh, before you go, comment it down. What are the things that I have missed out or you want to know more about it? And if you feel or come across any errors or any problems, feel free to write it down in the comment section in the YouTube channel or in the form in the coding section platform. Thank you.